Hi everyone, it's Mervin here from Cisco. So thanks for your time today and this afternoon. Just a couple of housekeeping stuff. There are evaluation forms on the chairs and no excuse for pens. There's a ton of pens in the back there. And for all you diehard code word guys that have been in the other sessions, we will have the code word announced in the presentation. So stay back. And we have our A2 booth, so come down, have a discussion. Most of the guys will be hanging around, so if you want an in-depth discussion, come along. So today I'm going to introduce Shannon McFarlane, which is one of our distinguished service systems engineer, and he's going to go through multi-cloud networking for you guys. Thank you.
Very good, thank you. The best way to reach me is on Twitter, IPv6. So if you didn't know what I used to do for about 12 years, didn't have anything to do with the next generation protocol at all. But at IPv6 is my Twitter handle. That's the best way to get a hold of me. We are going to briefly blast through some of the kind of the high-level concepts around multi-cloud networking. There's a lot of discussion around multi-cloud, and we're going to start off kind of doing a little bit of level set around multi-cloud networking versus hybrid cloud networking. And some of the things that we're going to talk about in here are 100% network transport focused. So if you're here to learn about how to stitch applications together and all of those types of things, we're not going to talk about that in here. What we're going to talk about is setting the groundwork in place for you to be able to have a transport that's reliable, highly available, and secure as it relates to linking on-prem workloads to public cloud workloads and even between public cloud workloads. So that's kind of what we'll be talking about in here today. So a quick agenda, we're going to do a level set around some of the things that we know and love about hybrid cloud networking that carry on into multi-cloud networking. We're just going to kind of walk through some scenarios and some topology views of extending network functions as it relates to transport elements between an on-prem environment to one and multiple public clouds. And then we'll start to kind of add on top of that. What is it that some of the pain points are when customers go down this path of really trying to extend their network elements and their network design from inside their enterprise or an on-prem environment and start to extend that into the public cloud? What are some of the pain points there, and what are some of the solutions that we have to get them there? And then we'll wrap it up around some of the automation challenges and some of the things that you can start to work on when you're faced with this multi-cloud networking dilemma that someone is assigning you to work on. So from a kind of a level set perspective, there's a lot of people from various vendors and analysts and all kinds of things that are really getting deeply involved in the discussion between what hybrid cloud is versus what multi-cloud is. Our context in here today is very, very focused on the networking element. So it's actually pretty easy to understand. From a hybrid cloud environment, we can see kind of in that top bullet point, we're just simply taking the network aspects of our data center, whether it be a private cloud with something like OpenStack, or it be vSphere or bare metal, or even a container-based environment in our own environment from an on-prem perspective, and we are now linking it into a single public cloud environment. Multi-cloud is just that all over again, with the exception of doing it to multiple public clouds, or it could even be only between public clouds themselves. It never touches on-prem. So the multi there aspect is just simply a keyword that's telling us that we're dealing with the same type of cloud or multiple types of clouds in different geographies. Now, what's good about kind of understanding, if you already kind of know and love hybrid cloud and you've deployed networking in that, a lot of the constructs and designs that you already know and love and have deployed roll right into a multi-cloud environment. What we're going to talk about, though, in here is some similarities of what you can take from a design approach, but there's also going to be some radically different things that you have to take into account when you start to stretch your networking environment to other types of clouds and kind of trying to understand a correlation between maybe what you're doing, for example, in a Neutron network to what you're going to do in AWS or Google's cloud or into Azure's cloud. And so we're going to kind of talk about some of those design aspects and how you can tackle them. Now, a lot of the technologies that we're going to talk about are applicable regardless of what cloud types you're using, but they can change on you. We'll talk about some of the considerations about what happens when you may have a very specific network requirement for one public cloud, but now based upon an application or based upon a region or based upon a project, that you may need to change your network topology requirements based upon those new requirements inside of the region or the project. Now, a lot of the common components that you guys know and love already are the core functions that we have to do no matter what public cloud or private cloud that we interact with. Things such as encryption. You want to privatize or encrypt the links between on-prem to public and between public environments. And so we're going to use the standard tool set of IPSec and ISAKMP and those types of aspects for encryption. Routing, obviously, is very, very important when we start to move into multi-cloud because you can't get by between one on-prem and one hybrid and maybe do it with a static route. You're most likely going to rely on BGP. And if you are going to really want to extend your internal on-prem interior gateway protocol stuff like OSPF or EIGRP, you're going to need to be able to extend that over a tunneled configuration. We'll be going on to some of those designs. Then the final aspect is we need to wrap all of these types of traffic patterns inside of some sort of tunneling approach. This can be GRE, MGRE, MPLS, L2TP, V3, many tunneling types out there that you can pick from and work with what is good from an operational perspective. Now, the last thing that we'll kind of talk through as we look at these topologies is what the network endpoint options are when you are engaging with a public cloud. So there's different aspects for each of these public clouds. One is known as the native VPN service. Native VPN service, as we'll talk about, is what does the public cloud give you right out of the box as a service to establish IPSec and to establish some level of static or dynamic routing. So we're going to talk through what some of those topology choices may look like and why you may actually not want to use them in your own environment. The second option that we're going to talk about is utilizing commercial or open source VPN technologies as a replacement for what the public cloud is going to give you out of the box. And again, we'll talk about the justification for why you need to look at that. Just because for the sake of time, we're not going to look at the co-location options. I've got links for a lot of direct connect, and express route, those types of technologies that each of the public clouds have, where you're basically linking your on-prem environment to a public cloud via a colo or a third-party colo facility to enable that. And we won't really talk about that in here today, but I'll be here for the week, and if you want to talk about that stuff, we can get into it. So the first thing that we want to talk about is why would you use multiple cloud providers? Okay, what would drive you towards using more than one public cloud provider in your environment? Well, one of the very first aspects that customers talk about is that they've built high availability and scalability in every aspect of their on-prem and public cloud environment, but they have not extended high availability to multiple cloud providers themselves. So if you're banking on all of your stuff into Australia East 1, for example, within AWS or Google, then you've locked yourselves into one cloud provider into one region. Okay, so you can build multiple availability zones within that region, but if that region goes dark or that cloud provider has a problem, you're in deep trouble if you're relying on your entire business in that particular aspect. So people will select multiple cloud providers as a means of cloud provider high availability. Another option here that kind of drives us is regional cloud provider access. So if you have maybe a merger and acquisition, or you are firing up a new line of business in a new part of the world, not everything feature-wise may exist in the region that you want to do business in. So you may have to go to a different provider that has those same type of storage aspects or those same types of Kubernetes deployments inside of the cluster. Whatever the case might be, you may need to look at different service providers within different regions to get you what you need. One aspect that we'll talk quite a bit about here is item number 3, which is around feature disparity. So this is going to be one of the drivers that is going to kind of part us potentially away from the native VPN services that a cloud provider offers and puts us maybe towards deploying third-party or a vendor-based routing architecture inside of that. And we'll talk quite a bit about that some more. And these other ones we'll actually beat to death as we kind of walk through this session, talking about some of the use cases around mergers and acquisitions and so forth. So this is a reference slide. So this is not all-inclusive of every public cloud provider that's out there. We're going to talk about the big three in here that the industry calls them, the Google Cloud Platform, Amazon Web Services, and Microsoft Azure. But there are many other providers out there, Telefonica, Telstra, many other options out there. And as they announced during the keynote this morning, there's a great way to go find some OpenStack public cloud references as well that you can deploy this in via the Passport program. So these are really the top three that we're going to kind of spend some time on in here today. So one of the things that we want to do in our deployment of connecting on-prem to a public cloud is just starting with a standard hybrid cloud environment. We're picking one and kind of crawling before we run. In this environment, we're basically extending our private network here that we have on the right there using some sort of on-prem private cloud or virtualization environment. This is, and you know, the people in this room know and love this, but particularly could be an OpenStack environment. It could be vSphere. It could be bare metal. But we simply want to link that network that is in our on-prem environment to a public cloud. In this particular example, we're using Google Cloud Platform, or GCP, and we are using their native VPN service. So again, when I say a native VPN service, this is a service that you would enable on that public cloud's environment that provides you two things. It provides you IPSec, and it provides you some means of performing static or dynamic routing. In the case of GCP, they have the Google Cloud VPN service, which is strictly the IPSec component. And then they have the Google Cloud Router, which is the BGP component. So in this environment, we're just simply establishing an IPSec point-to-point environment between our cloud and their cloud, and then optionally we're enabling some dynamic routing in that environment. Now, what you're going to see throughout this presentation is up on the right-hand side is that Cisco CSR is one of the options that allows you to have a virtualized routing instance running inside of a VM across KVM or OpenStack based or vSphere based, whatever the case might be. And that is really going to be something that we carry through the rest of this presentation, is having a very robust routing platform that we can run virtually or physically that links us into these public clouds. Okay, so we've started with this environment. So now we may start to extend our on-prem environment to our public environment by basically enabling more and more cloud types or more and more virtual router types. In this particular case, we've got an OpenStack deployment here on the bottom. We've got a vSphere deployment at the top. They're both running a Cisco CSR 1000V, and they are running IPSec environments into the public cloud themselves. So now we start to build kind of a framework for what we can now do moving forward, where we can just simply start to add more and more functionality, more and more high availability to get us what we need to from linking the workloads between our on-prem and our public clouds. We can also forgo the virtual environment and just simply use the physical stuff we already have. So we may be running a physical platform like a Cisco ASR 1000 or a physical firewall platform such as an ASA firewall. And again, just so we are meeting the basic requirements that the public cloud provider has for things like IPSec and for static routing or BGP routing, which is really the only thing that public cloud providers support. We can deploy whatever we want to on our side, okay? It really doesn't matter, just so that we adhere to kind of their minimums. So now we've laid this framework in a pure hybrid cloud environment. It's us talking to a public cloud. So now let's start to add more public clouds into the mix. Okay, so this is a good use case where a customer may, for example, have a merger and acquisition, where they are running, for example, on Google Cloud Platform today, but they acquire a company that is using AWS. Okay, so this is one of the top multi-cloud use cases we have with customers, where they're totally fine with the cloud provider they're using, but now they've acquired someone that they can't readily or quickly get off of that cloud provider and move over. So in this particular case, we're just simply doing what we did before, but now we're just linking into an additional public cloud environment. So in this case, we're running an AWS IPSec link, and we're running a Google Cloud Platform IPSec link. So as we kind of like start to mature this and we start to look at our application framework requirements, we can start to see that we have some suboptimal behavior here. For example, prior to our little checkered link that we had there, anything network-wise that is going to come from AWS's network into Google Cloud's platform network is always going to traverse the hub, okay? So this is just old school WAN technology, right? Where we've got a basically hub and spoke type of design. So one of the first things that customers will do in a scenario like this is they will go into AWS, they will go into GCP or Azure, and they will create a static IPsec point-to-point link between that public cloud provider to another public cloud provider, so that then they're not getting suboptimal routing. They're not traversing the hub or the on-prem environment to simply get linkage between two virtual networks within that environment. So you can start to see, as you expand this to multiple projects, multiple regions, multiple providers, that we start to run into a problem, right? This is the old school WAN type of issue where we have with mesh, right? Where I've got static point-to-point links spread out all over the world for multiple dynamic, very fast-moving projects, right? And so this becomes a real issue. So you can kind of see where this is going, where we need to enable something else that is basically giving us the flexibility and the kind of the dynamic VPN aspects that we'll need in a pretty rapid changing environment. So this kind of triggers some conditions that cause us to change our design. So this is where we kind of start to move through a decision process to move us away from traditional native VPN services within each of these public cloud providers. So I'm not going to read through all of these, but some of the big ticket items that kind of cause you to go through this is, why would I actually, outside of mesh, why else would I use something other than the native VPN services? So one of the big ones in the first bullet point is, the vast majority of enterprise designs I've ever worked with do not allow their internet-facing routers for public cloud consumption or their firewalls to be directly exposed to the internet. They usually place them behind either another tier of routers or firewalls, and they are usually behind IPv4 NAT. This is a problem if you're running Google Cloud Platform or Azure, because they do not support a feature known as NAT-T or NAT transparency. So when you are peering with Google Cloud or you're peering with Azure, you must have a purely routable IPv4 address on its outside interface, or they will break. You can actually show them in the log, and they just do really bad things, and the links never come up. So if you're running a NATed environment in your enterprise for these devices on-prem, you're going to need to put something into that public cloud that replaces that. Some of the other big ticket items is that the IPsec and IKE, which is the key exchange that we use for encryption, are very, very specific in each of the public clouds. So if you want to run a different type of dead peer detection, if you want to run a different kind of key structure between what you're running on your side and what they're running on their side, you may run into a situation where they do not support your key type or a hashing algorithm, whatever the case might be. The fourth bullet point is probably one of the biggest drivers for why customers want to replace the native VPN service, and that is that you want to extend all of your interior gateway protocols inside your enterprise into the public cloud itself. So a great deal of the enterprise accounts I work with want to treat the public cloud as either a remote branch or just another remote data center. So they want it to look, act, smell just like what they're running on-prem, but in a different location. So they want to have operational consistency, they want to have platform consistency, and they certainly want to have all of these sites look, from a routing topology perspective, like they're just another extension of the enterprise. You cannot do this in any way, shape, or form with a native VPN service that any of the providers have. Unless you happen to just know and love eBGP inside of all of your internal networks, which you probably don't, you're going to need to move on to something else. And one of the last things here that this is very powerful of is that, again, because we want to kind of treat this public cloud like it is an extension of a branch or of another data center, we may want to enable very enterprise type functions such as an MPLS VPN. We may want to turn on quality of service. We want to maybe have IPSLA or NetFlow from a monitoring perspective. And we certainly probably want to extend our enterprise tool sets from a monitoring, from a configuration, from a troubleshooting perspective, all the way into the public cloud. So one of the things that kind of ticks the box of everything in that previous slide is utilizing a Cisco innovation that's now out in the wild. There's other vendors that now have DMVPN. But dynamic multipoint VPN is a very, very powerful way for us to kind of solve some of the scale and mesh problems. It allows us to extend our interior gateway protocols across the DMVPN. It allows us to turn on quality of service. It allows us to run IPSLA and NetFlow. Many of those things that were in the previous slide as drivers become things that we just get inherently within a DMVPN environment. The problem here, though, is that if you remember our previous slides, we were utilizing native VPN services that were provided by the actual cloud provider themselves. In these examples, we are extending our CSR deployment into the public cloud itself. Why? Because we need to overcome some of the NAT transparency problems. We need to run an interior gateway that they don't support. We need to run quality of service that they don't support. So if we can extend the CSR into the public cloud, then we've now got good operational consistency and feature parity on both ends of our IPSec environment, okay? So in this example, we've got a CSR 1000V deployed in an Azure environment with a virtual network behind it. We've got a CSR 1000V deployed in an AWS environment. We have deployed dynamic multipoint VPN, which is incredibly powerful because DMVPN allows us to auto-discover all of the members of our VPN. So instead of going in and statically saying interface tunnel 0 source destination IPsec blah 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 for every single connection I have in my environment, I can spin up a single tunnel interface that auto-discovers all of its peers across that VPN. So now I can tear things down, I can build things up, I can add sites, I can add redundancy into the environment, and I can do it because that dynamic aspect allows me to discover all of the nodes that are participating in this cloud. So it really totally solves that mesh problem that we had before. So cool. We've got CSRs extended as virtual machines inside of each of our public clouds, and this is supported today. You can go into AWS Marketplace, you can go into Azure, and you can go and actually select the CSR. It will auto-deploy into your environment as an instance, and then you just basically configure your DMVPN properties from there. So it's very easy to deploy in that regard. Then you can start to really extend this multi-cloud environment where you can now start building in the framework for high availability and those types of aspects where we can now have high redundancy both within the cloud provider themselves and within the on-prem side. This also ticks off a lot of the aspects that we were talking about before, which are the top pain points for the enterprise, where we wanted to have IGP support. So if you actually took a look at the color change, all of our VPC networks were kind of a local network and with local routing inside of the actual cloud provider themselves. But now that we have a Cisco device on one end, a Cisco device on the other, and we have MGRE as a means to encapsulate these IGP protocols between them, we now just look at the public cloud networks just like they're any other network in our enterprise. So they show up in my IGP route table. I can do a show IP OSPF, and it will actually just show up with an IGP in there. So this is a pretty powerful aspect when you're an enterprise and you just don't want to treat everything as some foreign network location that you don't have access to. Now, the challenges with the multi-cloud and these types of designs is that we end up with a truckload of different tool sets. So when we were in good old hybrid cloud environment, we understood it's a vSphere environment or it's OpenStack inside of our private cloud, and we've got a single connection into a region for one public cloud, and I know their tool sets. Okay, great. So I kind of can deal with that environment where I've got maybe 2 or 3 different tool sets. But when we start to extend different tool sets for different jobs, maybe I'm running Ansible for some aspects, I'm running Python for others, I'm running, I think the internet's based on Bash, right? So, Bash may be the thing that I know and love everywhere. But when you start to now have to deal with that on your on-prem side and multiple public cloud providers, you run into a lot of challenge from an operational perspective. One of the big aspects that I see inside the enterprise realm that's definitely become a challenge is where you're looking at different automation frameworks. So that kind of second bullet point up there is where you may be orchestrating your environment in OpenStack with something like Heat. And you knew and loved, because you were an AWS shop, your CloudFormation templates, you could spin those things up in your sleep. Now an M&A comes along and they're a Google or they're an Azure shop. So now you've got to understand Deployment Manager. You've got to understand Azure Automation. So how much of this stuff do you go through for each of these public clouds before you kind of say, I've had enough? What else can I do? Is there a solution out there that allows me to kind of abstract or hide a lot of those aspects from me as it relates to a configuration tool? Then the final thing here is you also have the complexity of having multiple vendor products involved in your mix. So this could be like, for example, Cisco NSO or Cisco Prime or Cisco Cloud Center are things that are being deployed within our infrastructure framework, but you may have F5 load balancers, you may have Citrix, you may have a multitude of different other vendors that you have to take into account. So the bad news is there's really no silver bullet for all of these, right? It's a very complex multi-vendor, multi-platform, multi-cloud environment, and you kind of have to walk through these things very slowly. If you rush into them, like many of the energy accounts I've talked to, you're probably going to end up backing out and trying to solve the problem. So one of the things that I recommend is use what your team already knows, and then very rapidly build a gap analysis list that basically looks at what tool set you're using today, compare them against the new requirements in the new public cloud environments that you're deploying, and then come up with a gap analysis list. Is Ansible plus Python plus Bash going to do everything we need? Can I get by with mostly Terraform and some scripts? You got to build kind of a gap analysis from what you're using. Some of the other stuff that you want to do is then start to tackle those very painful, highly repetitive chores that you have when you're linking your multi-clouds together, and automate those things away. So those things that tend to be repetitive, they tend to kind of be somewhat dynamic, so you don't want to have this human error prone aspect to it, and you want to start automating those particular aspects. So some of the things that I typically do with a customer when they're talking about kind of moving to a multi-cloud environment and start to try to begin to get their head wrapped around the automation stuff is that I tend to use public cloud clients, the actual CLI derivatives that come from each of those clouds, G-Cloud, for example, or AWS CLI or Azure CLI, for services that don't change frequently or that need very unique, non-repeatable configurations. So for example, if you're not doing DMVPN and you're doing static IPSec VPN with pre-shared keys, guess what you get to do that's unique to each site? You get to do pre-shared key configs for every router, for every connection, for every tunnel, right? So that becomes very unique, but they are long-lived. They typically are things that once the IPSec connection's up and routing's working, it kind of stays there. So that may be something where you start with it with an actual native client. The next thing I tend to do is that I tend to start to use the actual native cloud provider automation tools if it's very specific to that provider. So for example, if I'm working in GCP and I'm doing a bunch of stuff for projects only unique to GCP, I will use the deployment manager for GCP. If it's AWS, I start burning CloudFormation templates and using that automation. Okay, so it's more localized to just that cloud provider. And then the final part there is that things that change a lot, I use REST for. So those are the three kind of interface types that you can always gain access to for every public cloud, is you can get to them through a CLI, you can get to them through their own automation framework, and you can get to them via REST. So if I am setting up someone's lab environment, for example, for them to kind of do a proof of concept, I can within basically about 15 seconds, depending on my latency, have a full static IPSec VPN with BGP routing and instances deployed by calling basically 8 REST calls. So you can very, very quickly do that by changing and tearing that environment down as much as you want to. So this is kind of the free way, right? We like free. Isn't that what everyone said OpenStack was? It was free. It's open source, right? Open source is free. I think I've spent all of my lifetime and all of my hair on free tools. Okay, so at some point when you're done pulling those things, you know, the last fibers of hair out of your head like I have, you may want to stop, you know, kind of looking at that at a per tool set, per project, per site basis. And you may want to start to look at something that can kind of help you out by front-ending all of these APIs for you and start to automate these things on behalf of you. And so something like the Cisco Cloud Center environment is one of those types of things that allows you to go in and say, okay, I'm going to have a vSphere environment. I'm going to have an OpenStack environment. I got Kubernetes going on. I've got Google Cloud. I've got AWS. And I need something that kind of makes sense of all of that and abstracts away the complexity of each one of those tool sets. So that's one of the areas that you can kind of invest in. I think Mervyn did a great talk earlier today. If you didn't get that, make sure you watch that on a recording, because he walked through those very things that you would go through from a Cloud Center perspective that would kind of allow you to abstract away a lot of that functionality that you're burning through in individual tool sets today, okay? So that kind of wraps it up for my part. We're going to spend some time on some Q&A. This is I think I'm the last. Am I the last? I think I'm the last for the day. Yes. For the Cisco Code Word competition. So if you haven't participated in that, you want to collect your Cisco Code Word, turn that in, and you get some fabulous prize. So for my particular section, this is the infrastructure, or the code word is infrastructure. So make sure you fill that out, and I will stand here and take some questions. Go ahead.
Sorry, hang on for a second.
Oh, sorry. Yeah, we're doing the microphone because we're recording this.
Thank you. For DMVPN, you're saying you can enforce QoS. How do you achieve that when you can control the underlying infrastructure? It's a public cloud connected over, internet.
Yeah. So well, I guess we got a mic, but I'll repeat the question. So. The point was with DMVPN, if you enable quality of service, how do you actually control the underlying infrastructure? It's the public internet, right? So that's the age-old quality of service problem over the internet, right? So when we're looking at quality of service, it's not necessarily just about reliably detecting something that has abstracted multiple layers underneath us. So for example, if I'm passing across multiple service provider boundaries like I would in an internet particular case, some of those aspects I can't control. But what I can control are standard classification, priority, and queuing from within inside the part of the network that I can support. So for example, the Cisco CSR is licensed on bandwidth. So if I am connecting from Google's cloud or Azure's cloud into my enterprise, I can implement a quality of service plan that says, okay, we need to make sure that, one, we never achieve more than 98% of bandwidth consumption. And out of that 98% bandwidth consumption, I want to slice the traffic up in these 7 different classifications. So I can enable traditional quality of service in that environment. Yes, at some point, the bottom line scenario is if the internet between point A and point B go away, I don't have any control over that. But I do want to control as much as I can, especially from inside the application classification that I do have. Okay. You just want out of here. You want the free prizes and you want a break, right? No questions? Very good. Well, if you do, I'm here all week. Hit me on Twitter or find me in the hallway, trip me or something like that, and I'll be glad to talk in detail. Thank you.
Guys, please fill up the